Welcome to the overview of data analysis. We'll learn what is data analysis, why use data analysis, types of data analysis, and the process of how data analysis works. So let's start. So what exactly is data analysis? So data analysis can be called as a process of collection, transformation, cleaning, and modeling data with the goal of discovering required or unknown information from data. The result so obtained are communicated, suggested, conclusion, and supporting decision making. So once organization adopt data analytics, they can use that data to analyze the causes of specific event or understand business objectives and directives and gain insights into the business to get an easy understanding. So there's this question that what is the difference between data analysis and data analytics? So data analysis is nothing but a subset of data analytics, okay? And data analytics is a broad field of using data and tools to make business decisions. So data analysis is a subset of data analytics. Okay, and there's also data science, which everyone would have heard about. That is a completely different scenario, though it does have a lot of similarities with data analytics. The next slide. So we have understood what is data analysis, but let's talk about who uses data analysis. So data analysis roles are widespread throughout the industries and are in the most demand right now. One with the top, it would be data analyst. So data analyst is nothing but a person who deals with data and perform analysis to give out results. And those results can be insights into data or performing modeling with data, which can make use of traditional ML algorithms or the modern machine learning algorithms. And business analyst, the second position, is someone who makes use of the same skills that data analyst would, but they would be more domain specific. Like they would be in more finance if they are business analyst in a financial industry, or they would be more into, say, a banking, BFSI. They would be more domain specific in the BFSI. And the same could be said in retail. The difference between data and business analyst would be the business analyst would only concern themselves with data regarding the business, not with the product or other sales ones. So business analyst would usually deal with different kind of business data, with stakeholder management, and at times during the agile function. The third role is business intelligence analyst. So this is the third kind of role. So business intelligence analyst, the name says it all. It's intelligent business. So this role would look into the business data and perform intelligence analysis. So that would mean they would derive as much insights as possible to give an idea about how the data is showing whether we are making a profit in the market. Where do we stand right now? How was our sales in the previous one, and how is it currently? That's what a business intelligence analyst would deal with. The last one is marketing analyst. So marketing analyst, as the name suggests, would be more into the marketing part of the work. So marketing data that deals with digital marketing data. So digital marketing usually deals with email marketing and social media ads, and there would also be metrics within those. And when you want to display or have an idea about the overview of how the last some time or how the last few weeks or month went, you will have to use the marketing analyst to analyze how the data worked and how the marketing data worked throughout the year. And then we'll be able to get an idea about how the market strategies have been at work and how our products are being sold out. So there are a lot of similarities between all of these roles. There are also other roles which would be quants analyst, which is quantitative analyst, which is more into financial, but less with code and less with programming tools. There would also be parts of analysis process, like ETL is a part of analysis, okay, and there would be someone known as an ETL analyst that would deal with ETL part of the data, but there would be a lot of similarities between ETL analyst and data analyst. So there is no particular same jargon throughout the industry. Every company would use different name for these roles. So what we need to know is, we need to know that the skills which match with all of them, and we need to get familiar with all those skills, and then it would be easier to become an analyst, and you can go on to become a business analyst or business intelligence analyst and data analyst. So the next slide. Now that we have an understanding of what data analysis is and what data analytics or data science is, let's get on to understand why do we even need data analysis. So the answer to that will be multiple answers actually. So one of them will be better targeting. So using data analytics or data analysis, I'll be using that word interchangeably, although they mostly mean the same since data analysis is a subset of data analytics. So using data analytics, organization can determine what forms of advertising reach their customers effectively, or they make an impact on those customers. So data enables this organization to understand what methods of advertising is actually having an impact on their product spread on, and which target audience should we sell our product to, whom should we advertise to get the demographics of these people. Organizations can identify the kind of advertising that effectively reach and impact their customers using this data analytics. This would enable business to determine what forms of advertising their goods have the greatest influence on the target market and what scale they might use such approaches. Now, there is another one, which is demographics. So what is demographic? Demographic would mean user information. That's what it would mean. So gathering data about who is buying the product and from which location is also important. So you can optimize your product through that location, and you can match the demand and supply there. It helps them understand whether the business is reaching the right target audience, are getting requests or sales from the market it cannot serve. This can also indicate the existence of the market that the business is unaware of and can mark an entry. So this does the company a great deal of work. The company has so much potential now because of using data analytics, and they can enter new markets, capture the existing ones because of data. That's the power of data when a company uses it. So there are also new innovations that are going on because of data. So data gives businesses a rough idea of the trends in the future in consumer behavior, enabling the business to make futuristic inventions, create innovative services that will put them at the top of the industry. With these inventions, businesses can maintain a sharp edge over their competitors. It gives companies insight in pattern of customer behavior. And the good thing about this invention is that the businesses can patent them and reap from them, while at the same time raking in profits, thousands and millions of profits, and cut cost of operation. So these are other ones too. It will do a lot good if the management wants to have a smooth and effectively run business. With a good system, the management can determine the sectors of the business that are draining the finances unnecessary and the areas that need more financing. This all is an example of using data analysis. Data science will have lot more applications. So let's have a look at how companies that you might know are using data analysis to profit themselves off. Let's talk about Amazon. So everyone would have heard about Amazon. Amazon, which is the biggest online retailer by a stretch, uses big data in a lot of ways. One of them is product recommendation. So even if you just take a short glance at a product on Amazon, Amazon will use that data being you using the web to glance at the product. Similar products will follow you on the page and in your social media feed. And in ads, not surprisingly at all, Amazon earns 35% of the annual sales through these product recommendations. You might notice this when you use different social media, how Amazon is actually using multiple sources of reaching you and promoting the products. There's also one more which Amazon uses a lot. That's called as dynamic pricing. So if you have ever noticed, if you check out a product over and over again, the price seems to increase. It happens because Amazon has tracked your intent. It knows what you actually want and knows that you might be willing to pay even more for the product. The same logic is used while selling airline ticket as well. That's a different part here. And let's get on to another company, a much famous one, Netflix. So Netflix, which is streaming platform for films. So Netflix is like a wicked cat actually. When it comes to product marketing, they collect data about the times during which different subscribers watch the show. Do they binge watch or watch over the weekends and other similar metrics? This tracking helps them serve just the right shows to their consumers. Netflix displays different posters of the same movie shows to different individuals based on their interest. Personalization at its best, right? They even have plans to create different trailers for different audience. For example, if a person likes a comedy movie, they're more likely to watch a violent movie if the trailer is filled with comic scenes. Now that's something Netflix is wicked at. They are creating amazing product marketing strategies. So that was something about why data analysis, why use it. You might have enough idea about how data analysis or data analytics is changing the industry that you know, how every company can benefit from it, and how you can make your business brilliant, and you as a user who you would want to be a data analyst can make some inference about how data analysis is changing the world. Next slide. Now that we have an idea about what data analysis is and why use data analysis, let us try to look into the types of data analysis. So yes, there are types into that. There are descriptive, diagnostic, predictive, and prescriptive. Let's understand each of them thoroughly. Okay, so descriptive analytic. So what is that? It's based on live data, tells what's happening in real time. Yes. So it is a simple surface level type of analysis that looks at what has happened in the past. You have data, you have everything within it properly, and then you use it to understand what this data is telling you. Since data is of the past, even past, it could mean yesterday or last month. Yes. And if we try to analyze the data, we have an idea about what descriptive analytics can tell us. So there are two main techniques used in descriptive analytics, which are data aggregation and data mining. So the analyst first gathers the data and presents it in a summarized format. And that is the aggregation part, summarizing, and then mines the data to discover patterns. The data is presented in a way that can be understood easily by anyone, not just data expert, by any audience. So analyst does even that. They understand why some visuals will work for normal audience and why they might not. Descriptive analytics, let it be known, it doesn't try to explain the historical data or establish cause and effect relationship. At this stage, it's simply a case of determining and describing the what. So what has happened, what's happening in real time. So this is descriptive analytics. Descriptive. Make sure you remember that word. So the next type of analyst is diagnostic analyst. So Diagnostic analytics explores the why. So you might heard the word diagnostic, right? Maybe when you would have gone to a health checkup. Yes? So diagnostic analytics tries to determine what the descriptive cannot do. Diagnostic analytics tries to get a root cause analysis of why something happened. Yes? Why things are happening. It helps us troubleshoot issues. Okay? And when running diagnostic analytics, analysts will seek to find first anomalies within the data. So there is a constant stream of data explaining this and this, and suddenly there's a big change. Why did that happen? So that's what they would try to understand. They would try to understand the root cause of why sudden dip or sudden increase in some value happened. That is anything that cannot be explained by the data in front of them. So let's take an example. If the data shows that there was a sudden drop in sales for the month of March, okay, the data analyst will need to investigate the cause of it. Not just show that there was a drop, but need to investigate the cause of it. Okay, this is diagnostic. They'll embark on what's known as the discovery phase, identifying any additional data sources that might tell them more about why such anomalies arose. Finally, the data analyst will try to uncover causal relationship. For example, looking at any event that may correlate or correspond with the decrease in sales. So this diagnosis of the data can help us understand why something has happened. So we have two parts now. One which tells us what's happening in real time or what's happened, and diagnostic which is telling us why is it happening or why it has happened. Now we had two types of analysis that told us about past and the present. Okay, now we want to know about what will happen in the future. And how can we do that? We can do that by making use of predictive analytics. So predictive analytics tries to predict what is likely to happen. This is based on historical data, and there's a lot of assumption here because that's what we have to take into fact. It assumes static plans and models. Okay, so this is where analysts start to come up with actionable data-driven insights that the company can use to perform their next step. Predictive analytics estimates the likelihood of a future outcome based on historical data and probability theory. And while it can never be completely accurate, it does eliminate much of guesswork from the key business decision. Predictive analytics can be used to forecast all sorts of outcomes, from what products will be most popular at a certain time to how much the company revenue is likely to increase or decrease in a given period of time. Ultimately, this predictive analytics is used to increase the business chances of hitting the mark and taking the most appropriate action. So you see the power of predictive analytics, how it helps us understand the future, or more I can say predict it. So it has the word predict in it. Then we come to the last one here, which is prescriptive analytics. So this is once you have the future output, which is from the predictive, what's the next step? We know what's likely to happen. What do we do? Based on current data, predefined future plans, goals and objective. That's what prescriptive analytics explains to you. In that, prescriptive analytics advises on action and decision that should be taken. In other words, prescriptive analytics shows you how you can take advantage of the outcome that have been predicted. When conducting prescriptive analytics, data analysts will consider a range of possible scenarios and assess a different action that the company might need to take in each scenario. It's complex analysis, and that might involve working with algorithm, machine learning, computational modeling. These are big jargons which won't be a part of this course, but it's something you can refer, you can learn about them. Moreover, the effective use of this prescriptive analytics can have a huge, big impact on the company's decision-making progress and ultimately on the bottom line. So this is a sink or swim for the company. We have had 4 types of analysis done. referred here, which is descriptive, diagnostic, predictive, prescriptive. So DDPP. So that's how we go around. That's how the industry jargon is. The first tells us about what's happening or what's happened. The diagnostic tells us about why something happened or why something is happening. The next, predictive, will tell us what's likely to happen. And prescriptive will tell us what should we do next if that's likely to happen. So this is all that's there in data analysis. And since the DDPP, the higher you go on that rank, the more complex it becomes. It's harder to do analysis. Prescriptive will be much tougher than predictive, which will be tougher than diagnostic and descriptive. And they have larger values. And the next slide is about the process of data analysis. Okay, we know why, what types of data analysis. Now let's see how the process of data analysis is. So there are 5 steps in it. Okay, and within that we have identifying the problem, designing data requirement. Okay, then we have pre-processing data, performing analytics over data, and at the last, visualizing data, or you can even say interpreting it. So let's go in deep with each of these. So the first one, which is identifying the problem, okay, or the business objective, or what we are trying to do. This is the first thing we need to ask. So you need to define why you're doing the data analysis. Okay, why is it even being done? Then you identify the problem of this entire need for it. You ask the questions, define the target of your data analysis, and you need to determine at this step of the entire analysis that you're going to do, what do you want to get out of it? This is the why and what of the data analysis process. So this step will define why you need data analysis and identify the problem. So before getting into the nitty-gritty of data analysis, a business must first define why it requires a well-founded process in the first place. The first step in a data analysis process is determining why you need data analysis. Okay, this typically stems from a business problem or questions such as, let's take some example of questions. Okay, so suppose there's a question like, how can we reduce production cost without sacrificing quality? That's a good question. That will be needing more analysis in the cost. Okay, and next question, what are some ways to increase sales opportunities with our current resources? And do customers see our brand positively? So for this, we might need to do a survey and analyze the data from that and how we rank. So this is the first step. We need to ask questions here before getting into the analysis. So in addition to finding a purpose, consider which metrics to track along the way. Also be sure to identify sources of data when it's time to collect. This process can be long, very long and arduous. So building a roadmap here will greatly prepare your data team for all the following steps that are yet to come. Without this step, data analysis won't be fruitful. So this step should be your priority. Next slide. So you're in the second step now, and in the first step, you have defined what you want to get out of the analysis. What is your motivation or your goal here? What next? The next step will be collecting data or measure. So collecting data based on the requirement. Okay, data requirement gathering. That's what we said before. So in this, after you have defined the purpose, you need primary information gathering here. It's time to begin collecting the data which is needed for our analysis. Okay, and also the nature of the data that you're going to collect will determine how in-depth the analysis is or how in-depth can you go with it. Sometimes you might not get a data which you can drill down into. That drill down would mean you can't go deep into. You might need to go a lot deep to answer a lot of questions. Okay, so this step of how to collect data or measuring it is important. And data collection starts with primary sources. These are also known as internal sources. We typically call them structured data. Now, these structured data are the primary sources. They would contain information about customers, finance, sales, and a lot. And then there comes the secondary data, are also known as the unstructured data, which are from the external source. This is both structured and unstructured data as well. These can be gathered from many places. Like, for example, if you're looking to perform a sentiment analysis, okay, that's something they use in data analysis technique. So when you're performing a sentimental analysis towards your brand, you can gather data from review sites like G2, or you can also use APIs from social media. So that is the place where data could be found. Now, this entire part in the data analysis process of collecting and measuring data is the data discovery. Now, this is very important after the first part of problem statement, because if you gather the wrong data, which might not help you to get what you want, it might not help you to get the objective of the first part, then your analysis could be all wrong and wouldn't really be fruitful. So taking care of this collection of data is the most important part after the business objective or the main objectives are laid down. So the next slide comes down to pre-processing data. So this is the third step, and here we clean the unnecessary data or pre-processing data. Once you have the primary data or the secondary data from the primary or secondary sources respectively, you need to clean it or pre-process it. Okay, and cleaning and sorting of data is done here. So once data is collected from all the sources, your team, the data team, will be tasked with cleaning and sorting through it, because you need to make that available data wrangled. Wrangle would mean there's a data that exists, you need to transform it, process it in such a way that that data at the final end will be useful for your analysis. You can actually do analysis based on that. You can identify and purge duplicate and anomalous data. So data scientists here are tasked with cleaning it extremely good, because not all data is good data, and they must identify and purge duplicate data and other inconsistencies that could skew the analysis to generate accurate result. So with advances in this data analysis and data science and machine learning platform, more intelligent automation can save a lot of time the data analysis has. Okay, now you're removing unwanted data points and major errors, right? So you may have to do the data based on your objective. So the first objective, again, I'm saying, is the most important one. So keeping in mind the first objective that you have laid down, you have to do analysis and you have to do pre-processing before that analysis. And this is actually a very long process. Okay, so you might require automation for cleaning this, but yet every automation might not work for every data out there. So each data source that you have will require different kind of automation, and each time you have to spend cleaning data and automating it will be a long process. So bringing structured data to your data, this is more likely to tidying up and fixing layout issues. Okay, as you tidy and organize your data, you might find some more important data you're missing. So you will need to fill it up. This step will make up for the mistakes that you have done in the second step, okay, which is of gathering the data. And since this is a very crucial part, if it's not done correctly, your results will be affected. So apart from cleaning this data, many analysts carry out EDA and discover patterns and trends they may not have noticed initially. This also will refine your hypothesis. Hypothesis is something that you set in the first part. Now, there's an old saying, if you're given 10 days to cut a tree, you will use 9 days to sharpen the axe. And if you do not sharpen the axe and keep on cutting the tree from the first day itself, you will never be able to cut the tree down. So you need to make sure your tools that you have at your disposal are well versed and you know to use them. And for that, you'll need to clean the data before. Okay, so make sure you have this saying in your mind every time you're using data. Clean it and then process it, then you can head on with your analysis. The next slide, the fourth step in the process is beaming, performing analysis or performing analytics over your data. So this is what we'll be teaching you. Okay, and for that, so the step is more about analyzing and manipulating the data. This can be done in a variety of ways. Okay, you can choose any method which will be heavily depending on the goals and the question. Now, there are descriptive, diagnostic, predictive, and prescriptive analytics method which we have talked about. So one way is data mining, which is known as knowledge discovery within databases. So data mining techniques like clustering analysis, anomaly detection, association rule, this is something for the future. This can reveal hidden patterns in your data which weren't visible previously. There's also business intelligence and data visualization tool. Okay, and this is where EDA is done, both of which are optimized for decision making and business users. These options generate easy to understand reports, dashboard, scorecards, chart, which will give you an idea about the data inside. Data scientists, which are different from data analysts, can make use of predictive analytics, which makes up one of the 4 data analytics used today, and predictive analytics looks to the future. Remember that. This can include a lot of steps, and models and algorithms are used here to get a deeper understanding of the data. The final step in the data process is visualizing your data and interpreting it. So when you're done with all the 4 steps, so interpreting the result by visualization is what we're going to do here. So you need to identify best methods to demonstrate insights based on analysis. Okay, now when you're done analyzing everything and you need to show your results out to the people who want the output, you need to do visualization. So this part is essential because it's how a business will gain actual value from the previous 4 steps. Explain the diagram here. Okay, so you are seeing the part which I explained here, which is demonstrating insights based on analysis, and we communicate this result and provide recommendation. We can also make use of multiple reports in visualization. You can take multiple visualizations and join them up together to create a dashboard which will contain all your KPIs and metrics. This is the key step to gain insight from the data and being able to apply these insights to your business. Interpreting data analysis results should validate why you conducted it in the first place, even if it's not conclusive, not even 100% conclusive. Like, let's take an example. Suppose there's an option A and B. Both can be explored and tested to reduce production cost without sacrificing quality. Now, business analysts and users should look to collaborate during this process. Also, when interpreting results, consider any challenges or limitations that may not have been present in the data. This will make a confidence booster in the next step. So this was the data analysis process, and by finishing this slide, we are done with the first module in the data analysis with MS Excel offered by the Knowledge Academy.